Let's revisit the Gaussian rationals for a moment, and let's construct a automorphism of the rational of these guys. And at first, it might feel like, well, there's lots of functions from Q adjoint I to itself. Can you just pick any function from Q adjoint I to Q adjoint I? And that has a high probability of being an automorphism? And the answer is, being an automorphism or being satisfying those two compatibility checks to be a homomorphism, with high probability it is an automorphism. This is actually very strict. Not a lot of functions are automorphisms. In particular, if you think about even just like the linear functions from Q adjoint I to Q adjoint I, there is a lot of them. This is like a two-dimensional Q vector space. And so just the linear functions from Q adjoint I to itself, there's like, I don't know, there's 2 by 2 matrices number of functions. So there's a 4-dimensional vector space of functions here. It's going to turn out there's only 2 automorphisms. So it went from 4 dimensions to just 2 total, not even dimensions, just 2. That's 0 dimensions. So so the answer is no. In fact, the opposite. Almost all functions fail to be automorphisms. And the thing is, and I know I said automorphisms and I said all 2 by 2 matrices. If you just look at the invertible ones, which is where like the automorphisms are naturally going to lie, it's still 4-dimensional. So everything I said was correct. Oops, that's not a question. So almost all fail to be automorphisms. So let's just try one. Okay, so a natural thing to try is, well, the identity. We're going to show that the identity is in fact an automorphism. The identity preserves absolutely everything. The identity, I want you to think about, is an automorphism. I want you to think about the identity as the I change nothing function. And if you change nothing, you must preserve absolutely everything. So the identity is an automorphism. Let's just do that check real quick. Let's call it ID. So let's say ID, which is notation I'll use quite a bit, is the function that takes in a p plus qi and spits out a p plus qi. All right, we need to check that the identity of p1 plus q1i plus p2 plus q2i is equal to the identity of p1 plus q1i plus the identity of p2 plus q2i. That is, we can first apply the identity to the sum, and this is sum the applications of the identity. So there's a slight order of operations reverse. Well, it's not a slight, they just reverse. They change the order there. On the left-hand side, the identity, it does not matter what you plug in. What it's going to spit out is exactly what you plug in. So the left-hand side is p1 plus q1i plus p2 plus q2i. And the right-hand side is, again, for our first term, we're going to spit out exactly what we plug in. I'm just going to surround it with parentheses. In the second term, we're going to spit out exactly what we plug in. Are these the same? Certainly these are the same. Okay, so it's compatible with addition. All right, let's show compatibility with multiplication. Well, it's the same. Just replace plus with times. Change what needs to be changed, and it's the same proof. All right, so that's that it's a monomorphism. because it's compatible. But to be an automorphism, it also has to be onto, and the domain and codomain are the same. Well, the domain and codomain are the same, so we just need to check that it's onto. And there's two ways of checking it's onto. All of these, the identity is automatically an automorphism, but it's important to be able to know how to do these kind of obvious checks. I don't like to use the word obvious, but these kind of checks where you don't really have to check anything. It's important to know the structure of them, and write in more sentences than I have. Well, there's two ways of doing it. There's at least two ways. I'll put it that way. There's the first way, which I like the most. It's that Q adjoin I is a two-dimensional Q vector space. And the identity is a vector space mapping. Well, it's a linear mapping. By the rank nullity theorem, which is a monomorphism, which is 1-to-1. It's automatically 1-to-1 because we're working with fields. By the rank nullity theorem, the rank of the identity plus the nullity of the identity is the dimension of the domain of the identity. This is the domain one, not the codomain. Well, the nullity is 0 because it's 1-to-1. And the dimension is 2, so the rank of the identity in this case is 2. Fantastic. So that means its image is two-dimensional. But its image is also a subspace of Q adjoin I, and that is two-dimensional. So it's a two-dimensional subspace of a two-dimensional guy. So it's everything. So since Q adjoin I, this one's the codomain, is two-dimensional. The identity is actually onto. The range of the identity is everything. Now this is kind of dumb in this example because we can just check, which we'll do in way 2. But nevertheless, the rank, what we're seeing here is we actually have in the background some linear algebra structure that we can leverage, that we can use. And that is the cool thing here. So that's fine, and that proves it's onto. Another way of doing it is let's pick something in the codomain. This one's going to be vastly simpler. But let's pick some P plus Qi in Q adjoin I. This is the codomain Q adjoin I. Then, what does the identity... We need to find something that the identity sends to P plus Qi. Well, the identity of P plus Qi is P plus Qi. So every output, every element of Q adjoin I is an output. Okay, so the range is everything, so it's onto. Whew. All right, so this tells us is an automorphism. Why is it an automorphism? Well, it's a homomorphism, so it's a monomorphism because we're working with fields. It is onto, and the domain and codomain are itself. Now, nothing is special about Q adjoin I here. So let me notice this. Nothing is special about Q adjoin I. If K is any field, identity from K on K, I'll subscript it with a K to indicate its identity for K, is an automorphism, always. Proof goes through almost exactly the same way. Okay, so, all right, so that's always an automorphism. The next video, this one took longer than I thought. The next video we'll look at an interesting example of an automorphism particular to Q adjoin I.